This next section is a method that is probably one of the more difficult methods used for solving quadratic equations, but the upside to it is it will solve any quadratic equation imaginable. So if you can give me any quadratic equation, it can solve what this method called completing the square. We'll be able to solve this equation, even if it doesn't factor, even if you can't use the square root property. This is a catch-all method. Now, like I said, the downside is that it is pretty involved, and there's several steps to the process of what's called completing the square. Now, when we say completing the square refers to, if you remember, a perfect square trinomial. The whole goal of this is we're going to create, in this equation, a perfect square trinomial. What's nice about a perfect square trinomial it factors to a binomial squared. I mean, you remember perfect square trinomials look like this. Say 4x squared minus, I got to think, 20x plus 25. That's a perfect square trinomial, and it factors very nicely. Remember, we go 2x times 2x, perfect square. That's a perfect square. We take one of each and multiply them together. We get 10x, and then multiply that by 2. That just happens to be our middle term. Even though it's negative, it doesn't matter. That still factors very nicely into 2x and a 5, and then the minus is just right there, quantity squared. It's two binomials, but they're identical, so we just write it as quantity squared. That is called a perfect square trinomial. And that's what we're trying to accomplish here, is to create a perfect square trinomial out of what we're given, even though what we are given is generally not a perfect square trinomial. All right, so the idea here, step by step, we are ultimately going to create a perfect square trinomial. We are going to complete the square. So step one of the process. Step one, you need to isolate the constant. You want your quadratic and your linear term together on one side of the equation, preferably the left side. That's how I'm used to seeing it. And then get the constant to the other side, to the right side. All right? So in this particular problem, 3x squared plus 12 equals 24x. I need to move this 24x to the left side by subtracting it. And I'm going to move this 12 to the right side also by subtracting it. So my first step, I would write this as 3x to the second minus 24x equals negative 12. And that's quadratic term, linear term, get the constant isolated. So isolate the constant on the other side of the equation. It's simple enough. Right? Just move it to the other side. Okay, step two. Also a very important step, not difficult at all. No one step here is super difficult, it's just there's a lot of steps to the process. Step two, when we complete the square, we cannot unfortunately have a number other than 1 as our quadratic coefficient. So if you have a number other than 1 as your quadratic coefficient, you have to divide everything in this equation by that quadratic coefficient. So I'm going to say divide by a. You know, the a in the ax squared plus bx plus c equals 0. Divide by the quadratic coefficient. In this case, I unfortunately have to divide everything by 3. Fortunately, I wrote this problem, so everything is divisible by 3. But if it creates fractions, it creates fractions, and it does a lot of times. So if you divide 3x squared by 3, we get x squared. Negative 24x divided by 3 is negative 8x. And negative 12 divided by 3 is negative 4. Right, so now we're down to this quadratic equation. Okay, now step 3, this is the big step. This is how we complete the square. So in step 3, what we're saying is if we look at the left side, ignore the right side right now, we have x squared minus 8x. That's a binomial. Well, if I add a number to that, I create a trinomial. Now, I don't just want to add any number. I want to add a number that makes this a perfect square trinomial. So I got to figure out what number I need to add to x squared minus 8x, just a number, no variable. The number I need to add to make that a perfect square trinomial. So how we do this? we're going to multiply 1/2 to the b, the new linear term. So in this case, that's -8. We need to multiply 1/2 to -8, then square the result. So multiply 1/2 to b, then square. Now that means we're taking it to the power of 2. We're not doing the square root. Don't get that confused. Then square the result. Right? And that's all you have to do. So once you have the quadratic and the linear term on one side, so the constant is isolated, and after you divide by that quadratic coefficient, then we try to complete the square. Whatever this linear term is, we're going to multiply it by 1/2, and then we're going to take that answer to the second power. So 1/2 for us multiplied to -8. That's my linear coefficient. So 1/2 times -8, well, that's -4. But now I have to take that to the second power, which is 16. Let's put that in a box, because that's like the special number. So if I add 16 to the left side, I'm going to get a perfect square trinomial. What I'm saying is x squared minus 8x plus 16 is a perfect square trinomial. That is a guarantee if we follow this process. Now, the problem is I can't just add 16 to the left side unless, of course, I add it to the right side as well. So I'm adding 16 to the left. It's a perfect square trinomial. I'm adding 16 to the right, so the equation stays balanced. Right? It's got to stay balanced. So that's step 4. So step 4, add result. The result you obtain in step 3, add result to both sides. Both sides of equation. So I should say add result from step 3 to both sides of the equation. So what is my new equation? My new equation becomes x squared minus 8x plus 16. I'll keep it in the box just to show you. Equals -4, also plus 16, because we got to keep this thing balanced out. All right, so I added 16 to both sides. Why? Because I knew that would become a perfect square trinomial. So step 5. Step 5, I'll say factor. PST. Factor that perfect square trinomial. Guaranteed it is one now. And simplify. We'll just say right side, I suppose. So factor this as a perfect square trinomial. Simplify the right side. That's -4 plus 16. Easy to simplify. So first of all, how does that factor? Well, that's x times x. That's 4 times 4. You notice one of each multiplied together is 4x. Doubled is 8x. So it does work. As x 4 minus, because that's minus, quantity squared equals -4 plus 16 is 12. Okay, last step, step 6. Solve using what's called the square root property. Now, the square root property, remember, was reserved for when you had x squared equals a number. So if I had x squared equals a number like 12, yeah, we're in business. X equals plus or minus the square root of 12. Okay, well, we have something just as good. We have x minus 4, which is still a number, to the second equals 12. So I can say this number, not just x, but x minus 4, has to equal plus or minus the square root of 12. So it's the same concept, it's just not plain old x, it's x minus 4. What are you going to do? Well, this is what you're going to do. So solve using the square root property, we're almost there. Square root of 12 does simplify. So let's simplify that. That's the square root of 4, square root of 3. got x minus 4 equals plus or minus 2 square root of 3. Now the whole idea is we're trying to figure out what x is. We could care less what x minus 4 is, so finish solving this by adding 4 to both sides. Now when I add 4 to both sides, I can't actually combine those. You can't add a 4 to a 2 square root of 3. They're not like radical expressions as we talked about when we were simplifying radicals. But what we can do is write the 4 first, and then write the plus or minus 2 square root of 3, and say, well, those are my solutions. Positive 4, and plus or minus 2 square root of 3. So, truthfully, my answers are 4 plus 2 square root of 3 and 4 minus 2 square root of 3. Those are the solutions to my original quadratic equation. So it's a 6-step process. It's involved, but no one step is overwhelmingly complex or difficult or, just something you can't handle. It's simple little things, but it's just a lot of simple little things, unfortunately. Right? I'll probably make another video showing a couple more problems using this because this is something that we do need to know how to do.